We start practical lesson number 2 by interchangeability, standardization, and technical measurements. Task 1. The connection size is set. Nominal diameter 63. Fundamental deviation and IT grade of the hole under the above the line H7, big H, and fundamental deviation of the shaft and IT grade of the shaft F7 under the line. Define feet type and feet formation system, hole and shaft limit deviations, hole and shaft tolerances, hole and shaft limit dimensions, limit clearances or interferences, feet tolerance, and draw a scheme of tolerance fields. And solution. First, feet type and feet formation system, hole and shaft limit deviations. You can see here fundamental deviation of the hole, it's H, IT grade of the hole 7. Fundamental deviation of the shaft, small f, IT grade of the shaft 7. And limit deviation, we use upper limit deviation of the hole, big ES, is equal plus 0.03 millimeters. Lower limit deviation of the hole, big E, is equal 0 millimeters. Upper limit deviation of the shaft, small ES, is equal minus 0.03 millimeters. Lower limit deviation of the shaft, small E, is equal minus 0.06 millimeters. Is fit in the hole system or fit in the shaft system? If we see H, it's fundamental deviation of the hole, so the fit in the hole system. If H fundamental deviation of the hole, then fit in the hole system. Draw a sketch of the scheme of the tolerance field. Zero line, nominal diameter is equal 63 millimeters. Tolerance field of the hole, big TD, big ES, and big EE, it's all for the hole, upper limit deviation of the hole and lower limit deviation of the hole, and tolerance field of the shaft, upper limit deviation of the shaft and lower limit deviation of the shaft, ES and EE, small. If the hole tolerance field is higher than the shaft tolerance field, then we have a clearance fit. If the hole tolerance field is below than the shaft tolerance field, then we have an interference fit. If the tolerance field is of the hole and the shaft intersect, then we have a transitional fit. So we have hole tolerance field is higher than the shaft tolerance field. So we have a clearance fit. The hole tolerance field is higher than the shaft tolerance field, so we have a clearance fit. Hole and shaft tolerances. Hole tolerance, big TD is equal upper limit deviation minus lower limit deviation of the hole, and we have 0.03 minus 0.03 millimeters we have. And shaft tolerance, TD small, is equal upper limit deviation of the shaft minus lower limit deviation of the shaft. And we have minus 0.03 minus 0.06. It's all equal 0.03 millimeters. For hole and shaft limit dimensions, maximum hole size, D maximum is equal nominal diameter plus upper limit deviation of the hole. Nominal diameter 63 plus 0.03, and we have 63.03 millimeters. Minimum hole size is equal nominal diameter plus lower limit deviation of the hole is equal 63 plus 0. We have 63 and 0 millimeters. Maximum shaft size and minimum shaft size. Maximum shaft size d suffix maximum small d is equal nominal diameter plus upper limit deviation of the shaft. And we have 63 plus minus 0.03. It's equals 62.97 millimeters. Minimum shaft size, d suffix minimum, small d. It's equal nominal diameter of the dimension, plus lower limit deviation. And we have 63 plus minus 0.06, and it's equal 62.94 millimeters. Limit clearances or interferences. For a clearance fit, the maximum and minimum clearances must be determined. For an interference fit, the maximum and minimum interferences must be determined. For a transitional fit, the maximum clearance and maximum interference must be determined. We have a clearance fit, so we must determine minimum clearance and maximum clearance. We have clearance fit. Maximum clearance, S suffix maximum, is equal upper limit deviation of the hole minus lower limit deviation of the shaft. 0.03 minus 0.06, and we have 0.09 millimeters. Minimum clearance, S minimum is equal lower limit deviation of the hole minus upper limit deviation of the shaft. And we have 0 minus 0.03, and we have 0.03 millimeters. And fit tolerance. Fit tolerance is equal the sum of the tolerance field of the hole and tolerance field of the shaft. Big TD plus TD small. And we have 0.03 plus 0.03 is equal 0.6 millimeters. And 7. Draw a scheme of tolerance fields. Zero line with nominal diameter, with vector of nominal diameter is equal 63 millimeters. Tolerance field of the hole, tolerance field of the shaft, tolerance field of the H7 with upper limit deviation and lower limit deviation of the hole. Tolerance field of the shaft, small f7, upper limit deviation, small es, lower limit deviation, small e. Limit dimensions of the hole and limit dimensions of the shaft. And the minimum clearance and the maximum clearance in this fit. It was task number 1. Task 2. The connection size is set. Diameter, nominal diameter 480. Fundamental deviation of the hole big H. IT grade of the hole 7. Fundamental deviation of the shaft R. IT grade of the shaft 7. Define fit type and fit formation system, hole and shaft limit deviations, hole and shaft tolerances, hole and shaft limit dimensions, limit clearances, interference, fit tolerance, and draw a scheme of tolerance fields. We start solution. First, fit type and fit formation system. We have fundamental deviation of the hole, fundamental deviation of the shaft, IT grade of the hole, and IT grade of the shaft. Upper limit deviation of the hole, BKS, is equal plus 0.063 millimeters. Lower limit deviation of the hole, big AE, is equal 0 millimeters. Upper limit deviation of the shaft, small es, is equal plus 0.172 millimeters. Lower limit deviation of the shaft, small e, is equal plus 0.132 millimeters. Is fit in the hole system or fit in the shaft system? If H fundamental deviation of the hole, then fit in the hole system. Draw a sketch of the scheme of the tolerance fields. Zero line and nominal diameter is equal 480 millimeters. Tolerance field of the hole H7, upper limit deviation and lower limit deviation of the hole, and tolerance field of the shaft. Upper limit deviation of the shaft is bigger than upper limit deviation of the hole, and lower limit deviation of the shaft is bigger than upper limit deviation of the hole. So there are the tolerance field of the shaft. If the hole tolerance field is higher than the shaft tolerance field, then we have a clearance field. If the hole tolerance field is below the shaft tolerance field, then we have an interference field. If the tolerance field of the hole and the shaft intersect, then we have a transitional field. So there are the hole tolerance field is below than the shaft tolerance field. So we have an interference field. We have interference field. Hole and shaft tolerances. Hole tolerance is equal upper limit deviation of the hole minus lower limit deviation of the hole. And we have 0.063 minus 0, we have 0.063 millimeters. Shaft tolerance field is equal upper limit deviation of the shaft minus lower limit deviation of the shaft. And we have 0.172 minus 0.132, and it's equal 0.040 millimeters. We continue task 2. Solution of task 2 for hole and shaft limit dimensions. Maximum hole size. D maximum is equal nominal diameter plus upper limit deviation of the hole. And maximum hole size, minimum hole size, nominal diameter plus lower limit deviation of the hole. So maximum hole size is equal 480 plus 0.063, and we have 480.063 millimeters. Minimum hole size is equal 480 plus 0 is equal and it's equal 480 millimeters. Maximum shaft size, small d, suffix maximum, is equal nominal diameter plus upper limit deviation of the shaft. And it's equal 480 plus 0.172, and we have 480.0, and we have 480.172 millimeters. Minimum shaft size, d suffix minimum, small d, nominal diameter plus lower limit deviation of the shaft. 480 plus 0.132, and we have 480.132 millimeters. Limit clearances or interferences. We have interference feet. For an interference feet, the maximum and minimum interferences must be determined, and maximum and minimum. Maximum interference and maximum is equal upper limit deviation of the shaft minus lower limit deviation of the hole, and we have 0.172 minus 0 is equal 0.172 millimeters. Minimum interference and minimum, we have lower limit deviation of the shaft minus upper limit deviation of the hole, and it's equal 0.132 minus 0.063. It's equal 0.069 millimeters. Feed tolerance. Feed tolerance is sum of the tolerance field of the hole and tolerance field of the shaft. Big TD plus TD small, and we have 0.063 plus 0.040, and we have 0.103 millimeters. Draw a scheme of tolerance fields. Zero line, nominal diameter of connection is 480 millimeters. Tolerance field of the hole, tolerance field of the shaft, upper limit deviation of the shaft, lower limit deviation of the shaft, upper limit deviation of the hole, lower limit deviation of the hole. R6 is tolerance field of the shaft, and H7 tolerance fields of the hole. Limit dimensions of the hole, limit dimensions of the shaft, and maximum interference and minimum interference in the fit. It was solution of the task number 2. And task number 3. The connection size is set. Nominal diameter 160 millimeters. K7, line H6. Define fit type and fit formation system, hole and shaft limit deviations, hole and shaft tolerances, hole and shaft limit dimensions, limit clearances, interferences, fit tolerance, and draw a scheme of tolerance fields. We start solution. First, fit type and fit formation system, hole and shaft limit deviations. Fundamental deviation of the hole K, IT grade of the hole 7, fundamental deviation of the shaft H, small h, and IT grade of the shaft 6. We find upper limit deviation of the hole, big ES, is equal plus 0.012 millimeters. Lower limit deviation of the hole, big E, is equal minus 0.028 millimeters. Upper limit deviation of the shaft, yes, small es, is equal 0, and lower limit deviation of the shaft, EE, is equal minus 0.025 millimeters. Is fit in the hole system or fit in the shaft system? If H is fundamental deviation of the shaft, then fit in the shaft system. We have H fundamental deviation of the shaft, so we have fit in the shaft system. Draw a sketch of the scheme of the tolerance field. Zero line, nominal diameter, tolerance field of the hole. Upper limit deviation is equal plus 0.012. Lower limit deviation of the hole minus 0.028 millimeters. And tolerance field of the shaft. Small es is equal 0, small e is equal minus 0.025. If the tolerance field of the hole and the tolerance field of the shaft intersect, then we have a transitional fit. So there are the tolerance fields of the hole and tolerance field of the shaft intersect. So we have a transitional fit. We have transitional fit. Hole and shaft tolerances. Hole tolerance is upper limit deviation of the hole minus lower limit deviation of the hole. 0.012 minus 0.028. It's equal 0.04 millimeters. Shaft tolerance, T small, is equal upper limit deviation of the shaft minus lower limit deviation of the shaft, and we have 0 minus 0.025 millimeters. And we continue solution of the task number 3. For item 4, hole and shaft limit dimensions. Maximum hole size, D maximum, is equal nominal diameter plus big ES. And we have 160 plus 0.012, and it's equal 160.012 millimeters. Minimum hole size, nominal diameter plus lower limit deviation of the hole. 160 plus minus 0.028, and we have 159.972 millimeters. 159.972 millimeters. Maximum shaft size, D suffix maximum, we have nominal diameter plus upper limit deviation of the shaft. 160 plus 0, and we have 160 millimeters. Minimum shaft size, D minimum, we have nominal diameter plus lower limit deviation of the shaft, and we have 160 plus minus 0.025 millimeters. It's equal 159.975 millimeters. Limit clearances or interferences. For transition feed, the maximum clearance and maximum interference must be determined. We have transition feed, maximum clearance, S suffix maximum. It's equal upper limit deviation of the hole minus lower limit deviation of the shaft. We have 0.012 minus 0.025. It's equal 0.037 millimeters. Maximum interference and maximum is equal small ES minus big E. It's upper limit deviation of the shaft minus lower limit deviation of the hole. We have 0 minus 0.028. It's equal 0.028 millimeters. Feed tolerance. Feed tolerance is equal tolerance field of the hole plus tolerance field of the shaft. 0.04 plus 0.025, and we have 0.065 millimeters. And now we draw a scheme of tolerance field. Zero line, nominal diameter is equal 160 millimeters. Tolerance field of the hole, upper limit deviation 0, lower limit deviation minus 0.025 millimeters. Tolerance field of the shaft, excuse me. It was tolerance field of the shaft, TD small, upper limit deviation of the shaft. It's fit in the shaft system. So first, it's tolerance field of the shaft. Upper limit deviation small es is equal 0. Lower limit deviation small e is equal minus 0.025. And tolerance field of the hole, big ES, upper limit deviation of the hole is equal plus 0.0012, and lower limit deviation of the hole minus 0.028 millimeters. Its limit dimensions of the shaft and limit dimensions of the hole. Maximum interference in the feed and maximum clearance in the feed. So we finished our 3 examples, and now individual task variants. You should do this task in your practical individual work. Do it now, please. You have the example and you have your individual task variants.